Here we have a problem on derivative. That is, we have to find the derivative of y equals to square root of x positive 1 with respect to x. Okay, so before we find derivative, our first step is to write the square root as an exponent. So how can I write the square root as an exponent? It's very simple. So whenever I want to write square root as an exponent, the exponent will be 1 half. Okay, here I can use a power rule of derivative to get the derivative of this stuff. So that is like the power rule of derivative is, let's consider the derivative of the function x to the nth power. So I want to find derivative of this stuff with respect to x. So to get the derivative of this one, what I need to do is I have to bring this exponent in front of the variable and subtract 1 from the exponent. So this is a power rule of derivative. So now I'm just going to apply the power of derivative to get derivative of this stuff on the right side. Okay, on the left side we have y. When I find the derivative of y with respect to x is just dy over dx. Okay, if I use the power rule over here, so first I have to bring this exponent 1 half in front of the variable and subtract 1 from the exponent 1 half. So then I'll be getting 1 half times x positive 1 to the power 1 half negative 1. Actually here we have x at the base. So we just got the exponent in front of the variable and subtract 1 from the exponent. So it's over. But actually there is a hidden stuff even in this derivative. So far here the derivative is done only for the exponent n. That is n is brought in front of the variable and 1 is subtracted from the exponent. So the derivative is done only for the exponent. By chain rule, we have to do derivative for the base x with respect to x. It will be just 1. Even if, when you times it by 1, the result will not change. Even if this stuff is multiplied by 1, it will be the same. So usually we don't mention. But when we get some other different base, we have to be very careful. But here we don't have x at the base, we just have x positive 1. And also, so far I got derivative over here only for the exponent 1 half. That is, I got the exponent in front of x positive 1 and subtracted 1 from the exponent. By chain rule, I have to get derivative for the base x positive 1 with respect to x. Okay, so what do I get if I get the derivative of this base x positive 1 with respect to x? So first, let's find the derivative of this x with respect to x. It's just 1. And 1 is a constant. So what is the derivative of this constant? 1 with respect to x. It's 0. Okay, so we get dy over dx equals to 1 over 2 times x positive 1. And the simplification of 1 half negative 1 is just negative 1 over 2. So times 1. Actually, we can even do this one separately, 1 half negative 1. So here we have a subtraction between a fraction and an integer 1. So whenever we do subtraction between a fraction and an integer, we have to multiply the integer part by the denominator of the fraction. So once I'm done with this multiplication, I have to take this 2 as a common denominator. So here I multiply this integer 1 by this denominator 2. So now I'm done with the multiplication. Now I have to take this 2 as a common denominator. So 1 negative 2, when I simplify this one, I'll be getting negative 1 over 2. So in this way, this 1 over 2 negative 1 is simplified to negative 1 half. Okay, so in the next step, dy over dx equals to, so when I multiply this complete stuff by 1, it will be the same. So it's 1 half times x positive 1 to the power negative 1 half. Okay, so dy over dx is equal to, so 1 over 2, and actually the whole stuff is having negative exponent. Usually we don't give the answer of a particular math problem with negative exponent. So let me try to make this negative exponent as positive. For that, I have to move this term to denominator. When I move this term to denominator, automatically the sign of the exponent will change. Already it's negative. So when the whole stuff is moved to denominator, the exponent will become positive. So I'll be getting x positive 1 to the power of positive 1 half. Okay, already we have discussed, like whenever we have square root and I want to write the square root over here as exponent, I just write the square root as exponent 1 half. But here for x positive 1, I have the exponent 1 half. So it can be converted to square root. So then my next step, it will be dy over dx equals to 1 over 2 times. Since the x positive 1 is having the exponent 1 half, this exponent 1 half can be square root, then you'll be getting square root of x positive 1. So now I got the derivative of the given function. So the derivative of the given function with respect to x is 1 over 2 times square root of x positive 1.